It's baseball. I don't like it. What's with all the red stitches?
Well, you see the stitches hit the air in a different way depending on how you grab it, how you throw it, and how fast it goes.
It doesn't feel any different to me.
That's because you're not professional.
Whatever.
You know what baseball reminds me of? An exponential.
How can this relate to exponents? Oh, because it draws an arc doesn't automatically make it an exponential decay graph. Besides, it's not symmetrical.
It could be, if you throw it very well.
I don't get math. Why do we need it?
That's because math is related to all of the world.
Well, what? How?
Well, for example, let's use exponents.
Wait, why?
Because we are just talking about them right now. How do you think exponents relate to the world?
I don't know. That's what I'm asking.
Well, you need to use exponents for division.
Division? I thought exponents were all about multiplying.
Not division, as in fractions. I mean division, as in cell division. You know the cut paper in half and see how many you get question, right?
The one where the number doubles all the time? Yeah.
That's the one example right there.
But that's just a question.
Are you saying that you never used paper cut ballot before?
Well, I'm not saying that.
There we go.
I see your point. But that's just one example.
Do you want an example with many links to our life?
Well, yeah.
Well then, since we are talking about exponents, let's talk about linear equations.
Wait, what do those two have in common?
They both follow a equational format. Exponents follow y equal ax to the b over t power format, and linear equations follow y equal ax plus b format. Plus, they can be shown on the graph.
I guess that makes it similar. So what are real-life examples of linear equations?
Real life example can be seen almost anywhere.
Okay, wait, I just got lost there. What?
You're asking me what does the linear mean?
Whoa, related to lines?
Is the world made of lines?
Yeah.
That means world is made out of a lot of linear equations.
What? That doesn't make sense. Lines are the same as linear equations.
Then what do you think the lines are?
What do you mean?
Linear equations are how the lines are formed. They express the slope, the location of the line, and its lengths and relations. Think of the world as a big graph. Can't you see?
Yeah, I guess that's right. But it's not like we ever use that fact.
Artists do, architects do. It's all about making things realistic.
Okay, I get it. So what about systems of equations?
Okay, why did you think of that?
No, it just seems to feel the same as linear equations, just with two equations and no y. They both have equations in their name.
Interesting interpretation. Actually, linear equations and system of equation can be exactly the same.
Well, how?
A system of equations are a numerical way to find out x variable. Then you can say the linear equations are a graphic way. Systems of equations are formed of polynomials, right?
Beg pardon?
You know what polynomials are, right?
Yes, it's a combination of several monomials.
Then do you know that equations are polynomials?
What?
Equation is a sum of several monomials.
Oh yeah. So polynomials are equations?
Not quite. Equations are polynomials, but they're not the other way around.
Wait, what does that mean?
Is 2 an even number?
Yeah.
That doesn't mean all even numbers are 2, doesn't it?
Oh, that's what you mean.
Anyways, system of equations are, in a way of saying it, the same thing as linear equations in different perspective approaches. In systems of equations, you use two equations to solve a value of variable x. In linear equation, you graph the equations and solve it for intersecting points to find a value of x.
Whatever. I'm just gonna play baseball.
So, you admit it now? World is made out of math.
Don't know. Don't care. I'm going.
Remember that baseballs are exponents.
Whatever!